One of my all-time favourite tape recorders was made by a company called Leevers Rich. They were quite large in the UK. They were used extensively throughout broadcast and film production. But I received this one just a few days ago, which has a little bit of history with it. This recorder is housed in a canvas bag with rope side carrying handles. This is the second one of such carrying cases I've seen. On the top here we have box S2, probably for Sound 2, Sound JWJ facilities. This particular machine is believed to have been used on a very particular film set. The case is quite fragile, but in very good condition. The machine inside has seen a lot of use though, so it's quite tatty. The one that I have in the loft, one of these machines in a case, is actually in much better condition. Now, sadly I haven't got a machine with one of these in good condition, but this is a connecting diagram for the amplifier to the tape recorder, and this one goes on top of the amplifier, and in the other lid should be a operating diagram for the tape deck. Sadly it's gone all together. So what do we have here? This is a Leevers Rich Series C tape recorder. As far as I can work out, there is no Series A or B tape recorder. These would have most likely been either acetate or a disc cutter. The earliest Leevers Rich that I know of, to my knowledge, is a Series C, which is that red one over there with a very low serial number. It's a similar kind of style tape deck, but the amplifier is slightly different. This one has a later style amplifier with the large MIP meter, which we see on the Series Ds and onwards the early Series Es. So this would be a late Series C. Now the earliest Leevers Rich I've got, it has more or less the same design tape deck as, say, the newest Type E. But there are several different versions of them, and this one, like I said, being the early Mark 1, we can see here a meter which isn't a VU. It's got a scale 1 to 12 for volts, and it's got a second scale underneath it from 1 to 5, which is probably dBs. We've got a speaker box at the back and quite basic controls. Then we look at one slightly newer. We notice straight away different colour case. Paint is similar. But then we've got an opening at the back here for putting your cables into. But we've still got this round meter. We notice on the one that we've got over here that it has the MIP meter, but not only that, it has a test oscillator. A bit difficult to see, but I'm assuming this is probably newer. This one has a black faced deck, a bit difficult to see. It's got the test oscillator in there. The tape deck is black. We see a difference in design with the S type. We have here low tension for 12 volts, high tension for the 300 volts, and we have a variable speed control. This is because the motor on this is designed to run on an external 12 volt power supply, and the motor speed can change. Quite often you want it to synchronise with a film camera. You have here a strobe wheel which strobes with a 50 Hz cycle. On the standard Series C machine we have a switch here for off, standby, which is your low tension 12 volt and valve heater voltage, and on, which is your HT. This is a power saving feature. Inside these machines they have a rotary voltage converter. What that means is that you put 12 volts into the motor starts to spin at high speed, and it generates a output voltage of around about 300 to 400 volts. This system takes approximately around about 5, maybe 6 amps to run. So having that switched off means that you're saving that power. With the amplifier in standby, you've got the amplifier valves heaters on. Keeping the heaters on all times helps prolong the valve's life. It also means as soon as you put it into on mode, the machine is ready to run within a few seconds. Now this machine has been modified inside. We have here a box, and inside there, mounted on rubber cushions, is the rotary converter. And here we have a transistor pack. This has been added at a later date by Elliott Brothers. We also have here a switch. That switch is used to switch between the rotary converter, which is that one, or the PALS inverter. I'm not sure why at the moment, if you've had a newer version, as in this 12 volt transistorized power converter, why you would want to carry on using a rotary converter, because as mentioned before, they're quite power hungry. They require servicing, where a transistor pack obviously is a lot more stable. I'm assuming this is a very early form of switch mode. If that's the case, it may be because of the reliability of components back in the days that these had issues of failing. If that was true, and that failed on site, you'd obviously need some sort of a backup plan. So having this switch here, you have the benefits of a lower powered, high efficiency voltage converter, and the reliability of, if it should fail, you've got a backup rotary converter power supply. This machine was actually in the rotary position, which may even mean that this box is faulty. Hopefully we'll find out. A quick look inside this box. We've got a small variable controller there. That will be for the voltage output, I would assume. We've got two transistors here, and we've got a small capacitor here. That looks like a switch mode power supply chopper circuit. So I would suggest, I would think this probably is a very early version of a switch mode power supply. It's nowhere near as complicated looking as a modern day version, which is good news, because if this has actually gone faulty, we've only got two transistors and three capacitors to replace. Hopefully the transformers will be fine. Usually when a switch mode power supply goes, these are fine. But on the modern day switch mode power supply, you quite often find one of the issues with them is what's called the chopper circuit and the timing capacitor, which I'm hoping is this 8 microfarad one here, tend to go faulty. But on a switch mode power supply, a modern one, usually if one component goes, it takes out a few others with it. Now something I've noticed, another modification, is this foam. Now in the original machines, they've got like a thick sort of like rubbery matting which goes inside, but not inside the tape deck. This has obviously been added as a bit of soundproofing, because as mentioned, we've got a rotary converter in there. It does make quite a lot of noise, and on the film set obviously you want to keep your noise levels to a minimum. So somebody's added this padding. But what I found is that this is loose, and underneath we have the circuit diagram. Now this one's not in great condition. I have got this one in manual, so I could probably reprint one of these out and re-stick it down there if needs be, but there's not really much point. It's not something really you see quite often, but it's there for an engineer who's out on site. The machine should fail, they've got the circuit diagram there to be able to help themselves fix it on site, so that they lose as little as possible time in production. And here we have the amplifier section. Inside we have no circuit diagram this time, because it's housed in the main tape deck, but we have a nice array of valves there, but also we have in the bottom here a row of replacement valves. If a valve should go pop on site, the engineer has the ability to just take out the faulty valve and put in a new one. Now this machine hasn't been repaired or touched in any way at the moment, but one of the problems is the VU meter glass has come loose and is touching the needle, so that needs to be sorted out before it's powered on. Opening up the meter to secure the glass is quite easy, but what isn't easy is when you find the meter is open circuit. So on a diode test, which is a handful of voltage, or the beep test in here, you can use it just to test the meter, just to see if it flicks. You can see that this one's sticking. You can see the other one over here. That one's sticking. Unfortunately on these ones it's because we have a soft metal arm here which bends and the needle sticks. These two are quite easily fixed, but this one unfortunately is something I couldn't do. So for the moment, as I can't repair the meter, I am simply going to use one of the spare that I have. Put the better scale, because as we can see there, this one's quite faded. Put the better scale in there, and then put that machine meter back together. The only worry is what actually caused the meter to go. From what I understand, it's the meter gets a small amount of damp in there and the coil goes open circuit. The other side could be that too many volts went through it and blew it. Now this machine may not have been switched on for over 50 years, and it's extremely possible that it will be faulty. This power supply will definitely not be enough to start it. However, it should be enough to help ease the machine back into life. So if I start him down at 5 volts, there's no limiter circuit on. Put on the the low tension, and straight away the power supply is running at 1.5 amps. If I turn that up so that it's limited to around about 3 amps. So the HT gives power to the motor drive, which at the moment I'm only running it at 5 volts. If I turn that up, we have some movement. We also have light on the VU meter, but we also have a power supply over there maxed out at 5 amps. If the camera will focus on it. This is just play mode. The machine hasn't got the HT turned on yet. In fairness to the power supply in the machine, however, I forgot to mention the brakes are on, and they're operated by these tension rollers. So if I try again, there's less drag, although the power supply still is over 5 amps. So the machine's not really on at the moment. We've just got 2 amps being drawn, powering the valves, heaters. If we turn the HT on, we immediately had a flick up to 5 amps there, and we've got nothing. Climbing up there to 2.5 amps. With the HT on, we can see we have low tension voltage, which kind of operates as showing as a battery level indicator. So we know the meter's working, we know the meter circuit's working. Sadly, however, now with the HT on, there is not enough power to power the machine and the VU meters and everything else properly. Power supply is now struggling over 5 amps. So I need a bigger source. Introducing a bigger source, my old van battery. So now we have enough power to run the machine. The lights aren't dimming out. The only downside is we haven't got any neon light, which would suggest we haven't got any HT. It would appear the rotary converter isn't working. So let's try the transistorized power pack. Certainly making an interesting noise. and that's now stopped making a noise. So with the tape on, sadly we have no sound output. We don't have any oscillator. Got a tiny click there, but nothing really worthwhile mentioning. So with the sound of the voltage or DC to DC converter or the switch mode power supply struggling to get up to the right frequency, I would say that there's possibility a heavy drag on the circuit. If you've seen my video on the film version machine, capacitors like this had to be replaced and they were causing too much of an issue for the machine and causing the sound quality and recording quality to be very poor. So it looks like as if this is no different, but this machine will probably need recapping. Interestingly, the rotary controller seems to have started to work. If I turn him on, now it certainly sounds like as if the brushes have gone, but that hum, that whistle, is a kind of sound you'd have at all times, and hence why the box has been packed out with something to try and quieten the sound. Something I do notice is the neon light isn't coming on either, which might suggest that the HT isn't working properly, but it could also be a capacitor of some sort causing a severe current drain. It might well be that the DC to DC converter here has put some life back into the capacitors, enough to make it less of a struggle for the rotary converter to actually spin up. Even with the case closed, you can still hear it humming. Now here's an interesting feature on this machine. Hopefully you can see this on this camera. You can see lines turning clockwise. If I change the speed, I can get them to more or less stand still. This is how, in a normal environment, on the inside environment, you get this machine to run correctly at 15 inches a second. Because as the battery power starts to drop, the speed can also change. If you're outside, however, there is no mains light to cause a strobe effect, and you wouldn't get that kind of effect. You wouldn't know what speed it was to work at. So how would you do it? The answer is to have an external device which can cause a strobe effect, so that you can relate to the machine. This was done by Leevers Rich by using a tuning fork. Now this one runs at 100 Hz, and unlike a standard tuning fork, it has a pair of shutters. These shutters open and close at 100 times a second. And what you would do is, inside here should be a little red neon light, and you'd hold these shutters up to the little neon light, and basically with the shutters opening and closing at 100 times a second, you'd then adjust the speed until it was correct. I have only ever seen this on a Leevers Rich tape recorder. Here's another modification. As you can see here, stop, play, record and rewind. There's no fast forward. Somebody's added a toggle switch to allow you to be able to rewind and fast forward. The idea generally is you wouldn't actually want to fast forward the tape. Like film, you can only use film once, and on the tape recorder you probably wouldn't want to go back on the sound because you'd end up erasing stuff you already had. Of course, in a modern day tape recorder, having the ability to rewind, fast forward, record gives you the editing functions, and which we all know recorders are used for. But when you're out on the field, in the field, you don't necessarily need to do any editing. You're doing everything post-production. You're making the master cuts, and generally you don't go back on the master cut. You keep everything, the bad bits and the good bits. As mentioned, this recorder has some history to it. The gentleman I purchased it off was helping a lady move it on. That lady's ex-husband was a sound engineer, and he used this machine to record on the set of Lawrence of Arabia. At the moment I haven't got names to put against it. I've got a strong feeling that that is all correct, and I'm hoping to later on publicise the fact that this machine was one of those ones used on the actual set. I haven't discovered who JWJ Facilities is yet. I've tried to do a little bit of googling on it, but I haven't found much information. Luckily, the lady who had the machine has agreed to contact me and write a letter which should shed some light on it, and it will be a nice little thing to have to go alongside this machine. So there we have it, the Leevers Rich Series Cs reel-to-reel tape recorder. Most probably one of the later versions, this machine being a portable battery operated tape recorder used most likely on the set of Lawrence of Arabia and possibly other sets. I'm sure once I've spoken to the original owner, more information should come. And hopefully sometime soon this machine will be recapped and will be in full working order. But until then,